Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 2-aminodiphenylmethane, 2-benzylaniline, which has an NH2 group on a benzene ring at the ortho position relative to the CH2 group connecting to benzene rings. Moving on to the next step. This is a diazotization reaction. The primary aromatic amine, NH2, reacts with NaO2 in the presence of H2SO4 to form a diazonium salt, Arn2+, at low temperature. Moving on to the next step. The diazonium salt formed is positioned ortho to the CH2 bridge connecting to the second benzene ring. The diazonium group can undergo intramolecular electrophilic aromatic substitution or loss of N2 to form a carbocation arine, followed by cyclization with the adjacent benzene ring. Since the NH2 is ortho to the CH2 group, the diazonium nitrogen is geometrically close to the second phenyl ring. Loss of N2 generates a highly reactive aryl cation, or the diazonium acts as electrophile that attacks the neighboring benzene ring. And for the final step, the intramolecular cyclization closes a 5-membered ring between the two benzene rings via the CH2 bridge and the new C-to-C bond formed. This produces fluorine, a tricyclic compound with two benzene rings fused to a central cyclopentane, 5-membered ring. Option A would require formation of a 6-membered central ring, but the CH2 bridge provides only one carbon, giving a 5-membered ring upon cyclization. Option C is anthracene type with 4 rings, which is not consistent with the atom count. Option D is naphthalene, 2 fused benzene rings, with no bridge carbon incorporated. The product with a 5-membered central ring connecting the two benzene rings is fluorine, matching option B. Therefore, the correct answer is B. Therefore, the correct answer is option B.